I want to welcome you to this session and introduce Kunal Anand, the CTO at F5. This has been an incredible partnership. We've done multiple cloud migrations, but not only migrations, but their multi-cloud network capabilities have allowed our customers to build a true hybrid cloud strategy. And we are furthering our partnerships with Microsoft, for example, in building a solution that is very simple to deploy, takes care of the data gravity, they take care of layer 3, layer 4, layer 7, and it's like a match made in heaven. And I want to thank Kunal personally for the reach out, because it was his vision that actually started this partnership and the co-engineering that we're doing together now. And it's I just want to applaud F5 for the innovation that they have brought to our products and help our customers bring data to where it needs to be. Over to you, Kunal.
Lindsay, let me give you a handshake. Thank you so much for the partnership.
Buddy.
Thank you.
It's awesome.
Thank you. All right, can you all hear me? Yes. Wow, echo. Thank you all for making the time to be here. And for those that would like a copy of the presentation, a copy of the slides afterwards, just come and find me after this talk. We'd be happy to pass that on to you as well. So the title of this talk is going to be about RAG, Retrieval Augmented Generation, and what we can do together between NetApp and F5. We fundamentally believe that as two organizations, as we come together, we can truly help people in terms of not just delivering these workloads and these experiences, but also helping secure those experiences as well. And I'll start with the general problem that we have today when it comes to artificial intelligence. Many of you are aware of, obviously, these large foundational models that are out there. So the OpenAIs, the Anthropics, the Geminis of the world. The one interesting thing about this is that those foundational models, very large and trained on a massive corpus, a massive data set, you know, it's interesting because they can't necessarily reason, but they can do some pretty interesting things because it has so much information and so much data. But we've all been there before, where we've sometimes asked GPT a question, or we've asked one of these services a question, and there's a knowledge cutoff. We sometimes get told, sorry, I don't have any more information beyond 2022 or 23 or 24, whatever it might be. And the other bit of this is hallucinations. Right? These systems still hallucinate quite a bit. And one of the interesting things that we have seen is, while these foundational models are very capable and house a lot of intelligence, they may not be the exact fit or the appropriate fit for an organization today. And what we have seen, and again, if you think about the ChatGPT moment, I think we can all remember generally where we were when we started playing with ChatGPT and experimenting with that technology. One approach that we saw organizations go down was building and training their own models. Interesting, right? But again, you can think about the complexity that's involved with respect to building and training your own models. You need a ton of expertise, and let's not even get into fine-tuning, where you need even more expertise for how to do this at scale. And of course, that requires not just resources on the human side, but also just a ton of resources on the technology and the platform side to go and properly scale this up. Now, you'll see that curve over here, a set of curves over there, which is around the projected timeline for training these foundational models. And what we're finding is there's another set of curves that inverts the other way, which is around the mean error rate of these models and the efficient GPU or compute frontier. And it's important to note that we are reaching that curve, and it's very unlikely that we're going to dip below that, which is also pretty fascinating. Now, the way that organizations have figured out a way around this is, you've got these models that are relatively capable, they can do a lot. What if we could marry our proprietary data, our organizational data, with those models, and could we start to do some interesting things? And it's fascinating because you think about RAG, right, Retrieval Augmented Generation, and this capability or this concept just didn't exist 2+ years ago. Because we just didn't, have these models. Now we have these models, and do organizations go down the path of building and training their own models? We're seeing some of that. We're seeing organizations go down the path of building and training small models, but how do they get the benefit of these larger models? How do they get potentially logical reasoning? How do they get chain of thought? And for those who have been following the news, OpenAI's most recent announcement, what they called Strawberry or GPT 4.0, that's interesting because that is the first time we're seeing chain of thought codified at scale. And so how do organizations take advantage of that? Well, they use RAG, and RAG's point is to marry proprietary data that organizations have and have captured to date, and marry that with, fundamentally, these really smart models, these intelligent models that are out there in the world. And so some of the use cases where we see RAG being deployed at scale, and as Yonzi mentioned, in my role, I get to travel quite a bit, and I get to meet with loads of customers across various segments. I'll give you a couple of examples. Customer service bots, or customer service agents, where people want to be able to leverage their own data, their own support tickets, their own cases with these models that already exist. So if someone has asked a question before and we know what the right answer is, we can supply that information to something like GPT. We can put it in the context window and then fundamentally allow the model to do what its thing is, but leverage our most recent data. The other bit is around reviewing contracts. For those in technology, you typically know how painful it can sometimes be to respond to RFPs, RFIs, or look through legal documentation when you want to work on a deal. One use case that we see is people are looking at all this plethora of information, legal information, case information, to make better decisions. And so that's just another example and another use case. And then the last one is obviously on the R&D side. Now, for the longest time, we had, and I say the longest time trivially, I guess, or in jest, because we've had copilots, code copilots now for a little more than a year and a half. What's fascinating is we're now starting to see use cases where people are looking at their own source code and using that as part of RAG for going in to generate a solution or generating more code. Don't just look at the corpus of internet data or GitHub repositories. Use my own data, look at my own source code to help me reason through and generate code that makes sense for this business. And so these are just a couple of examples that are all very different of how people are using RAG today. Now, of course, in order to make this work, you need data, right? Here's the challenge, and Yonzi called out data gravity in the introduction. I think everyone genuinely thought, and it's crazy to kind of go back in the DeLorean and go back 10 years ago, I think everyone genuinely thought that everyone was going to move from a physical data center to the cloud. There was a sort of speculation more than a decade ago, and I think we were all there, that we were going to be 100% all in, pick your favorite cloud services provider. But we didn't end up there. In fact, it's quite the opposite, where people have information truly everywhere. And the large organizations, the ones that are doing things like mergers and acquisitions, the ones that are expanding and growing or trying new things, they end up with this sprawl. A sprawl of information and data that's absolutely everywhere. And part of this thing and what's emerging out of this is called data gravity. Most of us are the ones that are already in, I would say, sensitive or highly regulated organizations know what this challenge is, which is we have data that is trapped in these environments, and they have to be there for legal or compliance or regulatory reasons. And it's unlikely that we're going to be able to move that data. So how are we going to actually take advantage of artificial intelligence? How are we going to take advantage of RAG when we have data absolutely everywhere? And that is something that is so top of mind for people now as they think about whether I'm going to train a model or fine-tune a model, or if I want to do retrieval augmented generation, how do I marry all of these things together, especially when I've got data in all of these unique silos? And to sort of think through it for a moment, let's zoom out and think through how these AI applications are working. And so this is a generalized traffic path for the way that inference is done today. And I'm being somewhat facetious and removing a lot of points in the middle just to sort of take a more zoomed out view. But you can see, let's say you have an application. Let's say it's a chat bot. Well, it's a customer service bot. The customer service bot is going to try and pull a bunch of information when you ask a support question, or you ask like a question about a ticket, or you file a ticket. It's going to need to go and fetch data from somewhere. It's going to go to a data store, a large enterprise data store, and you can see where this is going. And it's going to need to then grab all of that and feed it into what we now call AI factories. And for those that are unaware about that term, AI factory, we're seeing some really interesting things on both ends of the spectrum. On one side, you've got a class of organization who are building and scaling out these massive AI factories, basically a lot of GPUs clustered together with a proprietary networking stack, and they're putting it all together. And so when you hear someone saying that they're spending loads of money to get 10,000 or 20,000 GPUs, divide that by 500 or 600, and that makes up an AI factory today. And the laws of physics, basically pushing photons over optical cabling, that is the frontier and what really is the dividing factor for what makes up one of these AI factories. That's one extreme. We also see a lot of people that are using public cloud for doing inference, or they're using something like an OpenAI, whatever that might be, as a service on the other end. And to glue all of this stuff together, you need APIs. APIs are fundamentally the way that all this communication is happening. And whether it's over REST, there could be gRPC or RPC protocols that may be used in certain places. But fundamentally, in order to make these calls to an AI factory, these are not just web calls. This isn't just a regular TCP or an HTTP call. It's typically going over some defined API protocol that's been established. Now, go back to that first example. Let's say I'm a customer service application. I need to go and get a bunch of support information and case data. Well, the first thing you're going to do is you're going to go to the data store. And a great example of that is, and what we see in the field, especially when we go and talk to organizations, is they're relying heavily on NetApp to go and get that data, whether it's unstructured or semi-structured data that they're trying to retrieve to feed in back into these AI factories. And so part one is, okay, let's make a call, let's go and get all the data that we need to fulfill this request. Part two is, let's now go and feed this AI factory or this inference capability or set of services with all of that metadata plus the user's prompt or some proprietary prompt in place so we get the right answer. And so this way now you're marrying your data, you're marrying an organizational data store with these, let's say, frontier or foundational capabilities that are out there as well. And there was a quote earlier, right, from Jensen about NetApp, and I think this is absolutely true, is the fact that nearly half the files in the world are stored in NetApp appliances. And so when we go out and we meet with organizations that want to open up these RAG use cases, or they want to enable RAG at scale in their environment, it's obvious that they're going to look at what they can do with their existing NetApp deployments today at scale. And why we're here and what we're really excited about doing with Yonzi and team on the NetApp side is we believe that together, when you marry what we can do at F5 with delivery and security, plus what NetApp brings to the table with incredible and superior capabilities with respect to data storage, we think we can help usher in a new era around data mobility as well as security for all of these AI workloads. And by the way, AI is hot right now, right? This is why a lot of people are thinking now about RAG and how they marry all this data together. If AI didn't exist, by the way, we'd probably still get here because of the hybrid nature and the fact that all of us are sitting across multiple environments. And over time, we are going to have to access all the data in different silos. I think what we've just seen is an acceleration of what was going to be a natural order of things happen in just a short amount of time. So I just wanted to couch that there, because I know AI is everything to everybody right now, but there is a natural path that we are going down anyways. I just think there was a massive acceleration. And so we walked through those high-level diagrams of what we see and how we see the world coming together with respect to AI. And you saw me put NetApp in the diagram before. This is where what we can do at F5 plus what NetApp is doing at scale, this is what gets super interesting. There is the front door, what we call the front door of these AI applications. And again, let's take something like a chatbot. But for those that are somewhat uninitiated, there is you may be familiar with application security, or you may have heard of the OWASP top 10 as it relates to application security. There is an OWASP LLM top 10. And I don't know if you've seen that, but like that is its own bag of special, let's call it that. And there are some unique things there where you have to try and look at how you secure those chat apps or those chatbot applications, because you can still pass through things like prompt injections or people who are trying to do model theft through that AI application before it even goes down into an AI factory. But what we're able to see and what we're able to meet customers in the field around is really around 2 use cases, and we'll drive into that. But one is, how can we help with load balancing and ingest at the data store level? And then the second is load balancing and ingest at the AI factory level. But the more meta piece here is, how do we glue all of the data that's across all these different environments together? How can we help create a single network that allows for access to all this information, a network that can support security-related use cases regardless of where the data is stored in the format that it's in? And so what we're excited about is there's many, many use cases of how we're meeting NetApp and how we're finding these customers in the world that have these challenges that we can solve together. And so you can see all these columns. The column all the way to the left is around use cases. One of these use cases, and we'll actually kind of unpack this, is broaden the aperture a bit. How can we help with RAG in cloud environments? And so I'll actually walk through the Azure OpenAI service and capability and what we can do there. And then it goes all the way down, and we'll talk about Network Connect, and I'll unpack distributed cloud for you so you get a sense as to what we can do on the F5 side. You're obviously all familiar with the capabilities on the NetApp side. I will walk you through what the complement is on the F5 side to make these use cases come alive. But you can see it goes beyond the simple RAG use case all the way down to what we can do in terms of training, inference, sitting on top of S3 compatible storage, etc. And so we just see there's a multitude of use cases. These are just some of them that we're really excited about helping people solve. So I'll start with this one, which is the multi-cloud environment example. Again, this is an example that we hear a lot about. I brought up already that everyone is in this hybrid mode right now. People are and have data in all these different environments. How do they pull all of that information together? How can they create that single network across all of those environments? And what we've been building at F5 for many years now is what we call distributed cloud services. And the way we think about it is a network, and a network that can run and be managed by us, but with the ability to extend that network into your network or your networks or environments. And it's pure software. And the idea is that we can deploy a kit of technology, it's basically software, that can run in any customer environment, in any customer setup, and it will form a networking mesh. And a networking mesh that can help with mobility, it can help with use cases that we see of, people are migrating applications. They also are migrating data. They're moving data from on-prem to the cloud. They're moving data between different silos, different locations. We can help facilitate that. And so the best way to think about F5 in this context is, look, we're not a storage organization. We're not a compute organization. What we are is an organization that's operating at the network layer that's going to help deliver and secure those workloads. And when you think about distributed cloud and you zoom out, and what I think is new for folks and for those who are familiar with F5, you may be familiar with F5 as it relates to load balancing and big IP. But there is a massive cloud business that we've built, and a cloud business that starts with a cloud mesh that we scale, we manage for many customers globally. And it's not just operating at a layer 3 level. As Yonzi mentioned, there's layer 3, layer 4, as well as layer 7. So at the layer 3, layer 4 level, obviously there's networking primitives there. At layer 7, that's where we start to bring in additional capabilities. That's where we can start to bring in more ADC capabilities, whether it's around application, API security, looking at fraud and abuse. Now, there is the kit that we deploy and that we scale and manage ourselves in the cloud, but there's an aspect of this that customers can take and run in their own environment, and that's called AppStack. And what we call it right now is customer edge, and a customer edge that any organization, anyone can take many of these capabilities that you see here, put that into software, and run that software in any environment they want. And not just on a regular server, it could be at the far, far edge. And so when Yonzi and I started having conversations together, and as F5 and NetApp were having more conversations, obviously with things like RAG, it's not just going to be in large data stores in very obvious locations. It's going to be about how we connect data in all these silos that are going to be everywhere, including the far, far edge. And the neat thing is, with the software, it's highly capable of supporting those use cases. And I'll walk you through 2 visual examples. Let's take the example, and what you see around here is our distributed fabric, so our distributed cloud services fabric in the middle. And around here, I've painted various things. So there's locations, so it could be physical data centers, it could be various cloud environments as well. Now let's zoom into an example of, let's say you have a self-hosted large language model. A large language model that you may want to operate in, let's say, Los Angeles. Now you'll see around all of these different areas in the spokes, so the hub being the fabric, the spokes being these data centers or locations, you'll see CE. That stands for Customer Edge. Think of that as that app stack kit that I was describing that runs in your environment or can run in your environment. And so the neat thing about this is, over time, it doesn't matter. It could be ONTAP, it could be Azure NetApp Files, it could be more NetApp deployment that you've got globally. It could also be the ONTAP select that's deployed on-prem. And the neat thing about this is, we are that single mesh that allows an organization to take advantage of the data that's fundamentally deployed anywhere and feed directly in to that self-hosted large language model. Now I know not everybody is hosting their own language models, but for those that are going down that path, whether it's a large language model, if you're lucky to build out an AI factory and you've got the GPUs to do it, great. We're also seeing people building these small language models, SLMs. And as they build out those SLMs, guess what? There's not much knowledge in those SLMs, and so they're going to have to rely on the data that's around the network. And so this is just one of those examples of F5 and NetApp coming together to help organizations solve what we think is that data gravity problem. Now, there's another example. Let's say you're not going down the path of deploying a large language model on your own, and you're leveraging something like OpenAI. So again, let's start this process all over again. Let's assume that you've got OpenAI deployed as a service through Azure, and many organizations, the large ones, certainly do. One of the things that we can do the exact same way, at least as we think about it, is you may have, again, data with ONTAP. You may have ANF, right? Azure NetApp Files. You could have NetApp again deployed as a NetApp deployed again inside of Azure where you've got a CE already deployed. And of course, you've got that last example again being on-prem. How do we glue all of that together? So again, the nice thing about this is this mirrors that first use case, and it doesn't matter if it's your own large language model, if it's a third-party language model, if it's a service that you're using, all of this stuff can be composed by the network. The network can bring all of this stuff together. Now, the art and the science behind this is the CE that gets deployed in all of these environments. Well, that's able to do all sorts of routing, and we can solve for overlapping IP addresses. So what gets exposed are these CEs publicly or really up to our service, and then we are able to leverage those CEs for routing inside of each of those environments. So what's really nice is an organization can deploy a CE in each of these environments, each of these networks that they're in, and now we can bring that delivery, that security, all those rich ADC delivery and control capabilities. And so again, the highlight of this is, and of course, let's take something like these customer support bots. They're going to be relying on a large language model. They combine with what we can bring from the network side, and it's many use cases that open up. And this is just a simple example of looking at a chatbot, which is just like the hello world that we see in with respect to generative AI today. Now, there's other modalities and other capabilities that we can take advantage of, other locations where we can pull this information from as well. We're really excited about what this means. And I think as it relates to the cloud example over here, what gets me, and I think what gets Yonzi and others excited about this, is the fact that it brings a new level of security to where the data resides. Today, we're all having to, and I was a former CISO before, and I remember painfully what my world used to be like, where I had to go and craft policy and security policy and data governance policy in all these different environments, on-prem, in the cloud, and these hybrid environments. we can come in as an overlay across all of these sites, all of these geographies, and create that consistent policy, which I think is so, so important right now, especially when you look at what's happening in the world with cybersecurity. The second is mobility. We are seeing organizations lift and shift. We are seeing organizations beginning to go down the path of, I've moved my application workloads, I've moved my API workloads, now it's time for me to start moving some of these data workloads that I already have. We're seeing it. And as they go down that path, they can absolutely leverage distributed cloud to do that work. In fact, we've helped many organizations go down the path of migrations on the application API side. What's great is now opening this up, and as people are looking at moving their data, being able to now allow them to allow that data to go between different environments, or go from an on-prem environment to a cloud environment, one that suits their desire for not just today, but also the future. And then the last is just reduced overhead. Like I said, I've been there, I've done that, I've lived that nightmare of trying to manage multiple policies before. That's a bummer. And like, you end up building up these really large teams that are just doing nothing but policy enforcement all day, every day, and trying to manage that in disparate environments is really difficult. We can reduce that friction with that overlay and with distributed cloud services. Now, the other example that I wanted to click into is how we're helping people specifically with respect to not just RAG, but also AI training. Right, so we do talk to organizations that will go down the path of leveraging their existing data to train and even fine-tune models. Now again, not everybody is there, and not everyone is training a large language model, but we are seeing organizations take the first few steps for training these small language models, or SLMs. We are seeing that, and we're seeing it in places like financial services, banking, insurance. We see it in healthcare as well, where people are going and starting to leverage that data. But here's the thing, as people are doing that, they're putting extra load, extra strain on their existing data stores. Because when they deployed those data stores and when they architected those environments, they didn't know that RAG was going to be a thing, right? They architected these data stores in an era where they needed to support, relatively straightforward reads and writes. Architecture now has to evolve based on the fact that RAG is placing a much larger number of reads and writes back on the workloads. And it's not just writes, it's mostly reads is where we see it being crushed. So in customer conversations, it's storage across the board. It's not just with NetApp, it's across the board. People are relying on storage now, so they're reading more, and that is creating a lot of pressure on that part of the infrastructure. Where data lives, that is the most important and precious part of everyone's infrastructure. Coming and being in this world in technology for quite some time, I remember when the bottleneck was the network, the public network, and how do we build the right amount of load balancing stack so we can get all this traffic inside the data center. It's interesting because we have enough firepower now at the edge, at the global edge, and at the front or the ingress point of someone's data center. The real limiting factor now is, do I have enough scale at the data tier to support all of these use cases and these use cases that fundamentally matter? And so what we have been able to see and what we've been able to help organizations with is at F5, we also not just on the cloud side, not just also have capabilities on the cloud side, but we also have a robust set of capabilities through physical or virtual appliances, and that's called Big IP. And that's what F5 is fundamentally known for, and where we started our history and our roots of the business, is being able to do things like delivery and security through these appliances. And as people are deploying these AI factories, as people are going down the path of leveraging data, let's say in storage grid as an example, they're able to put F5 Big IP directly in front of those appliances, directly in front of those data stores, and we're able to help with being able to pull out significant resources from those data stores to feed back into RAG use cases or for training models at scale. So again, really interesting in two very different set of use cases. But it goes beyond storage grid as an example, and I think we're all aware of the fact that with ONTAP, there's a growing set of capabilities, growing set of APIs, right? For instance, S3. And so what we want to be able to do, and what we've been so focused on, is being able to support all of these S3 related workflows. And I think the beauty of the relationship with NetApp is we've been supporting S3 for a long time in Big IP, and we've been able to support things like Storage Grid. It's really exciting to see what NetApp is doing with ONTAP. It's really exciting to see what NetApp is doing with S3 there. And there's going to be more to come on that side. But fundamentally, we're able to help with fast layer 4. We can do all sorts of optimizations around fast HTTP. We're helping people not just adopt these S3 compatible data stores, but we're helping them move that data really at scale without revealing a customer name. We're able to really support a massive technology company today who's has this giant need for RAG, where they're pulling and making thousands of requests per second to these data stores at scale to serve these models that they've got deployed globally. And so this is a real thing that we see that organizations are going down as well. So again, two very different modalities. One modality where you've got your network or a series of networks and you need to find a way to connect these things. And this example is fundamentally different, which is I'm mostly a on-premises organization, or I need the ability to accelerate or support this really interesting high-performance use case around the NetApp deployment today. And what we just believe in summarizing this up is that everyone's data is just the most important thing. It doesn't matter what the large vendors and I would say the AI vendors are going to do. It doesn't matter what GPT does. It doesn't matter what Gemini does. These models are just going to get more capable. They're going to get smarter. But what they're not going to have is knowledge about your business. They're not going to have knowledge about your organization. They're not going to have knowledge about your customers. And RAG is just going to be a very important use case. And marrying proprietary data at scale with these systems, well, that is, I think, going to be the biggest unlock for AI. And I think that's what's going to allow us to hopefully push beyond that efficiency curve that you saw before of those large language models or those foundational models. And that combination, we think, is going to be super important for the future. And so I'm really delighted. I'm thrilled to be partnering with the NetApp team. We're really excited about what we can do today, and also really encouraged about where we see the future going as well. So that's what I wanted to talk about. That was the summary of the presentation. I know we've got a few minutes. Happy to answer any questions specifically about what you've seen today. And again, thank you all so much for the time. Appreciate you. And as I mentioned before, for those as I mentioned before, for those that want a copy of the slides or anything, feel free to come up afterwards. I saw some folks taking pictures from their phones. That's cool, but if you want a higher fidelity version of it, feel free to ask. We're very friendly folks. Any questions or anything? And if those that don't want to do it publicly, you're more than welcome to come up afterwards, and we can have a one-on-one or a set of discussions separately too. I'll give it the old, who remembers the TV show Saved by the Bell? Yeah, I won't do the 7-minute rule. That would just be awkward. But if there's no questions, class is dismissed, I guess. Thank you so much.